From the 12th century onwards, Latin translations of works from the ancient Greek, Arabic and Jewish scholars gradually became available in the West. Complete versions of Ptolemy's Almagest, Aristotle's Physics, Metaphysics, Meteorology, On the Heavens and more opened up a whole new range of ideas, methodologies and technical know-how, which were taught in the new universities that were being established around Europe. From this time, the flat earth idea seems to be almost forgotten, as images and written accounts of a spherical earth become prevalent. These include the work of scholastic philosophers such as Thomas Aquinas and Jean Buridan, and the most popular astronomical text of the Middle Ages, John of Sacrobosco's De Sphera, or On the Sphere. Until the 15th century, the most common variety of world map was the T&O type, which appeared to show the Earth as a flat disk, with Asia at the top, Europe in the bottom left area, and Africa to the right, separated by a T-shaped ocean and surrounded by an O-shaped ocean, often decorated with mythical beings and sea monsters. These mappa mundi, or maps of the world, were symbolic depictions of the known inhabited portion of the sphere, the oikomene, which was confined to the northern hemisphere, because although, like St. Augustine, they were aware that the Earth was a globe, monastic mapmakers believed that the Antipodes were uninhabitable and not worth including on their maps. They represented the Earth in its religious, political and spiritual aspects rather than in strictly geographical terms. Their maps featured images of Christ and kings, towers and turrets, Adam and Eve and the Garden of Eden, with Jerusalem placed at the centre of the world to highlight its place in the metaphysical rather than the literal heart of the world. With flat earth belief firmly consigned to the ancient past, from the mid-16th century, debate became concentrated on the supposed position and motions of the terrestrial sphere. Central to this development was the work of Polish astronomer Nicholas Copernicus, who published On the Revolution of the Celestial Orbs in 1543. Shockingly, the book challenged the Aristotelian Ptolemaic geocentric universe, which had dominated astronomy for approximately 1800 years. Copernicus posited a heliocentric system, where the Earth became just another planet in orbit around the Sun, rather than the fixed centre of the universe as the subject of God's special creation. In 1616, the Catholic Church banned books that argued in favour of the motion of the Earth, fearing the impact this might have on biblical interpretation. Nevertheless, the Copernican idea was expanded upon by German mathematician Johann Kepler, who discovered that the planets did not trace a circular course around the Sun as Copernicus had thought, but instead moved in ellipses. Meanwhile in Italy, Galileo Galilei was using a telescope to make a number of discoveries that contradicted the Aristotelian system, with empirical proof of a Copernican sun-centred universe. And in England, mathematician Sir Isaac Newton published his famous works, the Principia in 1687 and Optics in 1709, combining mathematics and astronomy and presenting a rational, well-regulated cosmological system. By analysing observed facts, Newton seemed to impose order and regularity with general principles such as the three laws of motion and the principle of universal gravity. Book 3 of the Principia provided theoretical proof that the Earth is not a perfect sphere, but an oblate spheroid that bulges slightly at the equator due to its rotation, a hypothesis which would later be confirmed by 18th century French expeditions. Throughout the 18th century, aspects of Newton's work were adopted by Enlightenment thinkers, who believed that if overarching laws could be discovered that describe the world around us, then why not human beings and society as a whole? Radical thinkers promoted the idea that careful observation and the collection of empirical data, rather than the contemplation of abstract principles, could uncover the laws governing human existence, and that humankind was no longer at the mercy of strange forces beyond its comprehension. This was somewhat ironic, as Newton was a Protestant Bible scholar, astrologer and alchemist who saw science, philosophy and theology as inseparable components of one great whole. Newton had not removed God from the equation. He believed that the deity intervened in his creation from time to time. But Newton's religious views and the realities of natural philosophy were ignored by Voltaire and his contemporaries, who glossed over the religious, astrological and alchemical aspects of his work in keeping with their programme of sweeping social reform. It has been estimated that around the time Newton published the Principia, it was read from cover to cover by less than 100 of his contemporaries, and fully understood by just a fraction of those. In the 18th century, heyday of the popular astronomy lecture, speakers confronted this issue by boiling down Newton's work into more easily digestible versions, enthralling their audiences with visual aids, models, orreries, simple demonstrations, and illuminated lantern slides, while the coffee houses and academies of Europe provided further platforms for the explanation and popularization of these Newtonianisms. Expositions, dictionaries, handbooks, and fictionalized accounts also became important channels for the dissemination of these key ideas. By the 1830s, ideas about the Earth and its creation were also changing rapidly. While medieval theologians had not interpreted Genesis word for word, 17th century churchmen and scholars had begun to promote a literal reading of the Bible. The book of Genesis seemed to describe the creation as a series of sudden miraculous God-inspired events that could have occurred as recently as 4004 BC, according to one well-known estimate. According to the Bible, this established a fixed and unchanging natural order, a great chain of being from God to man to the lowest life forms. By the 19th century, this system was being challenged by the flourishing young science of geology, where new techniques enabled the surveying and mapping of strata and the fossils they contained, in chronological order, an innovation connected with amateur geologist William Smith, the first to work out the correct succession of strata in England and Wales. In his book Theory of the Earth, 1795, Scottish geologist James Hutton had argued that the Earth was created by a never-ending cycle of slow changes over a very long period of time. This theory, known as uniformitarianism, was fully articulated by barrister-turned-geologist Sir Charles Lyell in his controversial 3-volume Principles of Geology, 1830-33. Debates on the issue were heated and ongoing, but the basic tenet of Lyell's theory that the Earth had an extensive history eventually became the mainstream view. Meanwhile, sequential fossil finds revealed that the Earth had passed through a number of geological ages, each with its own species of animals and plants. French paleontologist Georges Cuvier had discovered that mammoths and mastodons had once existed, but become extinct, challenging the biblical view of a fixed, unchanging great chain of being from God to man to the lowest life forms. Although Cuvier advanced the idea of huge geological catastrophes followed by new creations by God to explain new species in the fossil record. Even more radical were the evolutionary ideas of French naturalist Jean-Baptiste Lamarck. In his book Zoological Philosophy, 1809, he advanced a theory that the simplest forms of life had originated in matter as the result of a series of physical and chemical reactions, a type of spontaneous generation. This living matter, forced to adapt to its environment, had transmuted, or evolved, passing on its acquired characteristics to the next generation, producing higher and more complex organisms until the development of man. Lamarck's ideas had limited impact on his peers and the public, as they failed to provide an adequate explanation for what made the life forms grow and develop. A mechanism, natural selection, was later discovered by Charles Darwin and Alfred Russel Wallace. However, Lamarck's theory introduced the abominable notion that man, supposedly the highest being created in God's own image, had evolved from the most menial life forms by a natural, non-divine, self-motivating mechanism. Cosmology again challenged the Genesis account with the nebula hypothesis, a theory proposed in the 18th century by German philosopher Immanuel Kant, and refined by French physicist Pierre-Simon Laplace. The nebula hypothesis taught that the stars and planets originated from immense diffuse revolving clouds of cosmic gas and dust, nebula, a process that, when taken at its most extreme, dispensed with the need for creation and a creator altogether. Although some ideas, such as transmutation, were so radical they were deemed taboo, most theologians were able to integrate the new geological findings into a liberal reading of the Genesis story. At a time when most geologists were Anglicans, it was common for them to explain the great age of the Earth by interpreting the 6 days of creation as long geological ages, day-age theory, or by incorporating a series of catastrophes and new creations into the Earth's history to explain the fossil record. It was also held that the existence of God could be demonstrated by the study of his creation, and that the world was so perfect in its design, it was evidence of a higher power at work. In 1802, clergyman William Paley's Natural Theology, or Evidence of the Existence and Attributes of the Deity Collected from the Appearance of Nature, famously used the complexity of the human eye as an example of deliberate, intricate invention by God. Thus, natural theology was used as an ideological prop for the existing social order and the political status quo. Fine for the parsons in their cosy country parishes, less satisfactory for the child workers in the mills. It is here that history takes a strange twist indeed, defying expectations about the progress of knowledge from varying points in the human past. For the flat earth idea has undergone a revival through the 19th, 20th and 21st centuries, the work of a movement of true believers determined to prove that conventional scientific knowledge is a delusion, the Bible is literally correct, and the earth is flat. While flat earth belief is widely ridiculed, it remains a central point of departure between a literal interpretation of the Bible and the findings of science. Despite its apparent absurdity, flat earth belief therefore occupies a unique place in the relationship between science and Christianity. It raises issues central to science education, the uses and abuses of information, the making of knowledge about the natural world, and the psychology of human faith.